Good evening, everyone. I'm Niketa. I'm a PhD student who might with us, and I'm the field of business development. And today is the extra session. So, today we will be looking at the overview of all the topics that we discussed about. So, first, let's talk about what is environment. So, environment refers to anything, everything. Uh, So this can include both the components and the so biotic components include all your living features. But the first two, the non-living part. So together, the biotic and abiotic components together form one environment. And why are we studying about this subject, about nutrition and the environment? Because we need to conserve carbon is very sensitive and we need to preserve the environment and also remove the leaves. So that is the we can study this first. And now that we first know how to remove the pollutants, we should be able to know more about the itself. So pollutants or waste can be classified into so the first one is solid waste, the waste. So all these three are different kinds of pollutants which may exist along with each other in the environment. And in order to protect or conserve the environment, accordingly, we will be solid waste environment. Even before we talk about removing pollutants, existing pollutants from environmental media, we can look at how these pollutants are coming into existence. Like you said, there's some sort of industrial sewage. Like it is important to look at what processes these wastes are coming from. And to minimize or restrict their so if an industry uses certain raw materials which would cause pollution, so that raw material needs to be changed or some alternative needs to be put so that the pollution is not caused. So that is the first step. Conclusion is yes, many many systems for protecting the environment This is where since simply live. So it is important to conserve our surroundings, protect not just our lives, but also the lives of other beings. So it is the study of just the humanities, the beings, the mind, and so finally the biological components can be classified into species. So you get out of energy channels. So source energy first they can apply molecules or plants. So what this means is some excess also for energy and the electrons present or plants take up the sunlight and they do a process called photosynthesis where solar energy is converted into uh, sunlight is converted into energy. And these plants when they are consumed by animals or human beings, there is some energy transfer happening. So the energy from plants they transfer like cell organisms which are the neurotrophs. And when these neurotrophs die, they become these further decomposers. Decomposers are also called as microbes or some other groups of living beings that we want us. So there is a transfer of energy. Uh, Ultimately, the sun's energy goes to decomposers. Chain, which is basically chain of organisms. So depending on which organism is eating which, so present like first set to chain service of humans. Sorry, my this like you. So reduce. Herbivores are consumed by carnivores, and carnivores they die. They are carnivores when herbivores and carnivores die, they are consumed by scavengers. So when these scavengers die, scavengers include the grass rodents, then crows, vultures, and all. And then when they are dying, the people start decomposing. Microbes, which feed on the property using the airports are also using. Here we have something called food web. So food web is nothing but particles with nutrients which are interlinked together. So it is something here. Why would you interest like this? So this is when we were organizing consumes after organizing. We started, let's say, there is a polluted water, and this is our consumption the water. So for water, is taken different fishes. So the concentration of pollutant in the fishes, we slightly higher than what is there in the water. So from fishes, many fishes are consumed by young organisms like birds. So there is a transfer of pollutant from the fish to the water. And when organisms are consume multiple fishes, so number of the pollution that is going to possible side the living bodies will be large. So this effect is called biomarketing. So it's small quantity, the Brazilian constellation gets becomes right, and it reaches the ultimate consumers. That is the long. So, humans are one of the last or the most probably the very last consumers. Similarly, this supposed to be providing which tells us what is the amount of take of the substance can actually because we calculated like when cancer. So substance is carcinogen, then we make the CDI, we see this will be multiplied the body weight of the chemistry. For non-carcinogens,
For non-carcinogens, the hazard quotient is defined. So the HQ value is equal to the intake or the CDI for a non-carcinogen divided by the reference dose. Now HI is the hazard index, which is the sum of hazard quotient. So if you have multiple pollutants, then HI is defined. So this will give us the sum of all the hazard quotients for each pollutant or non carcinogen. So if the hazard index is more than 1, it is unacceptable. And another criteria is lethal dose 50 or LD50. So LD50 means the dosage at which 50% of the organisms will die. So for example, if you have a population of about 100, and of that we give some, and in that population we I mean if that population is exposed to a pollutant, and if at a certain dosage the 50% of the population is dead, then that dose is called LD50. So pollutants in the environment can generally be classified into natural or man-made pollutants. And they can also be classified based on the source into point and non-point sources. So once a pollutant is released into the environment, it undergoes certain processes. So what happens after its release is called fate. So fate of pollutants first, it gets dispersed, so dispersion happens, and then there is dilution and deposition. So if it is some sediment, then it gets deposited. So especially it happens in river beds, and then degradation. And pollutants in water can be classified into physical, chemical, or biological. So physical pollutants can be suspended solids which cause turbidity, chemical solids which are chemical pollutants which could cause hardness, and other examples are heavy metals, and biological can be microbes or pathogens. So when we have a organic pollutant and it is released into a water body like maybe a river, what happens there is the microbes tend to degrade the organic matter, and for this they use up the dissolved oxygen in that river. So this leads to something called oxygen depletion. And in order to show this better, we have something called a oxygen sac curve. So an oxygen sac curve is basically a depiction of how the oxygen concentration varies before the pollutant was added and after its addition, and then how the oxygen levels vary throughout the process. So first we have the clear zone where the oxygen level is constantly maintained, and the level of oxygen which is present here is 8 to 9 ppm. So this is the maximum concentration of dissolved oxygen or the saturation concentration in water. So it is constantly maintained at 8 to 9 ppm in the clear zone or the clean zone. And when the pollutant is added at this point, the oxygen level starts decreasing because of microbial action, and slowly it becomes low. So this is the pollution or the pollutant zone. So this is where the pollutant is added. And then it reaches a point where aerobic conditions no longer exist. So the conditions become anaerobic, and this is called the septic zone. And then after some distance, the oxygen level starts increasing again because whatever organic matter was there, it is completely degraded now, and there is nothing else left for degradation. So the oxygen level starts climbing up because microbes no longer need the oxygen for the degradation process. And then there is the recovery zone. Where oxygen levels slowly starts increasing, and then the level becomes equal to the clear zone. So this is again the clean zone. Okay, now coming to air pollution. So types of air pollutants can be generally classified into two categories. The first one is particulate pollutants. The second one is gaseous pollutants. So particulate pollutants include PM10 and PM2.5, whereas gaseous pollutants include SOx, NOx, and carbon monoxide. And there are two types or ways in which particulates move in the air once they are released into the environment. Pollutants, actually. So the first is by diffusion, and the second is advection. The third step is convection. So this is a combination of diffusion and advection. So the difference between diffusion and advection is diffusion happens due to concentration gradient or concentration difference, whereas advection, here the pollutant moves because of any velocity or some kind of a force. Then we can define the lapse rate or environmental lapse rate. So there are two types of lapse rate. Lapse rate is basically the change in temperature as we move, as the height from the, the change in temperature as we move upwards from the land. So there are two kinds of lapse rate. The first one is the adiabatic lapse rate, which is usually 9.8 degrees Celsius, and then the environmental lapse rate. So, depending on the conditions of adiabatic lapse rate and environmental lapse rate, the environmental stability varies. So, the stability can be classified into these are the different types of stability classes: unstable, neutral, and stable. And the concentration of a pollutant at a given point can be given using the formula. Now let's talk about groundwater pollution. So before going into groundwater pollution, there is something called hydraulic conductivity. So hydraulic conductivity is the ability of a substance to transport water. So that can be given using the equation Q equals KIA, where Q is the flow rate and this is the so Q is the flow rate. K is the hydraulic conductivity. I is the gradient, which is also equal to h by L, or height by length, and A is the cross sectional area. So, moving on to solids in water. So, the total solids in water can be classified into two major categories. First one is total volatile solids. The second one is total fixed solids, and then settlable solids. So the total volatile solids can be subclassified into volatile dissolved, and volatile suspended solids. And the total fixed solids can be classified into dissolved and suspended. And when it comes to pollutant analysis, there can be two methods. The first one is qualitative analysis, and quantitative analysis. So, quantitative analysis can be volumetric, gravimetric, or weight based. The first one is volume based, and then instrumental. So coming to instrumental, in instrumental we have seen in detail about chromatography. And there are two major there are two equipments that we saw in detail. One is the gas chromatography instrument, and the second one is the liquid chromatography instrument. And then we saw about measuring the DO or dissolved oxygen. So this can be done using the Winkler's method. And then there is then we also saw about biochemical oxygen demand or BOD. And the chemical oxygen demand, or COD, and then total organic carbon, or TOC. Now let's talk about air pollution management. So for particulate pollutants, we can use gravity settlers, and electrostatic precipitators. We can also use fabric filters. And cyclone separators. And we can also use methods like wet scrubbing. And for gaseous pollutants, we can do absorption and adsorption. And for oxides of sulfur, we can use wet scrubbers. And oxides of nitrogen, we can use catalytic conversion, which is typically used in vehicles. For the treatment process, the wastewater coming from the source is then screened, and after screening it is taken to coagulation and flocculation. So this is the treatment for water. and after coagulation and flocculation, there will be sedimentation. And after sedimentation, there is disinfection. And after disinfection, the water will be stored for usage. So in the tertiary process, we have a process called filtration, where we use size separation to exclude the pollutants and separate water. And then we can also do ion exchange. So this is also similar, but here so the cationic pollutants will be attracted by the anionic resin and it will be removed. And similarly, the anionic pollutants will be attracted to the cationic resin and they will be removed. So this is ion exchange. Now coming to wastewater treatment. So here the raw sewage is taken for screening and then to a grit chamber. And then to an equalization tank. And then to a primary settling tank. And then it is taken to it is taken for biological treatment. Following this, we have secondary treatment. And this is followed by tertiary treatment. So in this whole process, the pre-treatment stage covers the processes of screening, grit chamber and equalization tank. So together, these three processes constitute the pre-treatment step. And then the primary settling tank comes under the primary treatment. And along with the secondary settling, so together these two, the biological treatment as well as secondary settling, come under the secondary treatment category. And then we have After secondary tertiary treatment, we will do disposal. So the secondary treatment process, there are different types of secondary treatment. They can be, this treatment process can be classified into aerobic or anaerobic process. So this is a broad classification. And under aerobic process, there will be suspended growth, attached growth, or hybrid. So some examples of aerobic processes are lagoons, which are open, or activated sludge processes, activated sludge process, and trickling filters. Now coming to anaerobic processes. Examples of anaerobic process include up to anaerobic sludge blanket or UASB. And then there are other treatment processes like without using microbes, which use plants. So this is called phytoremediation. So these processes are low cost and they are also energy efficient. And then there is also bioelectrochemical treatment. Here the type of electrode, electrolyte, and the substrate and the type of oxidant all will determine the reaction efficiency. Under tertiary treatment, we can have processes like absorption, filtration, and membrane processes. And then we can also have advanced oxidation processes. Or AOPs in short. So here the difference is that AOPs use oxidative radicals like hydroxyl or superoxide radicals, which will degrade the pollutants. Okay, now coming to sludge management. So the specific gravity of sludge is given using the formula 1 by fixed solid by total solid divided by 2.5 plus volatiles by total solids by 1. So this is the formula for calculating the specific gravity of the sludge. And to concentrate the sludge, that's the first step in sludge management. First we have to concentrate the waste. So this can be done using gravity thickening and flotation. And after concentration, we have to digest the sludge using microbes. And then after digestion, we have to do conditioning to remove excess water. And then this is followed by dewatering. And then oxidation. So once all the steps are complete, the sludge is either disposed using landfills or by open dumping, or it can be used as fertilizer and soil conditioner. So for composting is basically converting the solid waste into some useful substance like manure, which can be used for agriculture. And in order to do this, we need to look at variables like oxygen concentration, the type of microbes, the carbon to nitrogen ratio, and the moisture content, and the particle size of the waste. We also need to look at factors like temperature and time. So there are different types of composting: conventional, vermicomposting, using earthworms, and also uh, using rotary drums. So sludge digestion using anaerobic digestion. There are different processes that come under this anaerobic digestion. The first one is the hydrolysis step, and this is followed by acidogenesis, and then acetogenesis, and finally methanogenesis. And then we saw the solid waste classification. Solid waste can be classified into domestic, industrial, or agricultural. And again, it can be classified into biodegradable, and non-biodegradable. So let's look at the process in which waste is managed. So waste generation is the first step. So after generation, the waste is handled or separated, and then it is collected, and then it is transported, so after transport, it is disposed sometimes if it cannot be further processed, or the collected waste is segregated and it is processed and transformed. Now, after this, it is finally disposed. So, the containers that are used for waste collection can be either stationary or it can be a hauled container. So, you've seen the difference between the two. Okay, let's look at how waste is disposed. So, waste disposal can be done by open dumping, and landfilling, or by putting into the sea. So, this is also called barging. And coming to landfills, so landfills can be classified into secure or class 1 or class 2, which is normally used for municipal waste, and then for as a sanitary landfill. Now coming to hazardous waste. So hazardous waste is waste which is corrosive, ignitable, reactive, and toxic. So, in order to reduce the generation or reduce the solid waste, so this is an inverted pyramid that can be followed. The first step is to refuse to dispose any waste, or refuse to buy any substance which could cause any pollution. And the second step is to reduce consumption. The third step is to reuse as much as possible. So instead of dumping it or throwing it away, we can reuse the product as much as we can. And then repurpose. And finally recycle. Then we've seen various processes by which waste can be disposed. The first one is incineration. So incineration is the controlled burning. So before burning, we have to dry the waste. So drying is the first step. And then pyrolysis and char combustion. So there are certain factors which decide the incineration. So those are time, temperature, and turbulence, or 3 T's. And then we saw processes like gasification, pyrolysis, etc. And then we also saw about air quality index. So it is derived from the concentration of 8 major pollutants. One or two of them should be mandatorily PM10 or PM2.5. And then we saw about special waste. So special waste consists of biomedical waste and e-waste. And then we also saw about managing medical waste. So first, medical waste needs to be collected, segregated, stored, transported, and then the final step is treatment and disposal. So the way to reduce e-waste is first by reducing production, and also by recycling. So with this, we've come to the end of the live session. So thank you all.